Hey there, geometry students. It's Mr. Pouts, and this is section 7.1. We're starting off section or chapter 7, which is all about similarity, so similar things versus which is not necessarily congruent but similar. And we're going to start off with ratios and proportions, a good review from some algebra. So the goal for today is I can write ratios and solve proportions. There we go. All right, a couple vocab as we get started here. First one, what is a ratio? Well, a ratio is a comparison of two numbers or quantities. It's as simple as that, just comparing two numbers or quantities. And we'll talk about the different ways you can see a ratio written. An extended ratio, a ratio comparing three or more numbers. And so you can have a ratio instead of having, so if our ratio right here would be A to B, whoops. So instead of having A to B, you could have the ratio of A to B to C. And there's some instances where that would take place. And finally, a proportion is an equation that states that two ratios are equal. So we'll do many proportions where you have to solve for a missing piece oftentimes. But if you're saying 1 over 2 is equal to 3 over x, and then we can solve that for x. And we know x would be 6 in that case. So let's start off with ratios. All right? And there are three different common ways that ratios are written. The first one is, and the most common one, I'll say, is fraction form. So if we're comparing A and B, this would be written like this, A over B. All right, the second one, I guess, probably the second common one, but would be with a colon. And we'll just say A to B. All right, and the third one that you might see is just in words, the ratio of A to B. All right, so here's something that's important when we're talking about ratios. When we're comparing or when we're doing ratios, just basic ratios, it should be in the same units. So whatever two things we're comparing should have the same units, because if they're different units, then it's a rate. We're doing just regular ratios, and in simplest form, so simplify them. So let's do a couple of examples here of doing that. So the first of all, um, example 1, it says write the ratio of the first measurement to the second measurement. We have the length of the car and the length of the model car. So two things that would be similar. If we're comparing the length of the car, we know it's 14 feet 10 inches. And the model is 8 inches. So I'm just going to fill in the blocks here so that they're the same units. So 14 feet 10 inches would be, well, 14 times 12. Then you add, whoops. Whoa. I'm going to actually grab my calculator so I don't get it wrong. Just to check, 14 times 12, it's going to be around 168. Then you add 10 to that, so it's going to be 178 inches over 8 inches. So those are the two comparing numbers. Now we also have to write it in simplest form. So if we divide it by 8, we'll see if that'll work out. If not, we'll have to reduce it a different way. So it doesn't quite work out. So we're going to multiply it back by 8. But another common thing you could divide both top and bottom by would be 4. I think 4 might work. We'll try it. Does not work. So we'll just divide them by 2. So it'll be 89 over 4. That is the reduced. That's the simplest form of this ratio. All right, now the second one, I'll start you off, but just know that there's 16 ounces in a pound. So this would actually be 0.5 pounds on here. And in simplest form, it's not okay to have a fraction or decimal on either in part of a fraction in this ratio. So let's simplify it and make it so that there's no decimal on the bottom, and I'm going to have you do that on your own. All right? All right, so hopefully you realize that to change that, we just multiply both the top and the bottom by 1, so that this is actually a whole number, and it's in its simplest form of 1. You have to multiply this by 2 as well. So multiply both of them by 2, and that would get you 29 times 2 would be 5,800. All right, so 5,800 pounds to 1 pound when we're comparing the weight of the car to the model car. All right, number 3, it says there are 238 juniors at a high school. It's a big class. The ratio of girls to boys in the class is 3 to 4. How many juniors are there? Well, how many are boys? So how many juniors total? If 238 total, and the ratio of girls to boys is 3 to 4, there's a couple different ways you can go about doing that. We know that the number of girls would be, if it's girls to boys, this would be 3 out of a total of 7. This is a ratio. So if there's 7 total, it'd be 3 out of 7 times that 238. So girls, let's see, 238 times 3 divided by 7. Because again, if you're not sure on how we did that, 102 girls. Because if you look here, the ratio is 3 boys to 4 girls, or 3 girls to 4 boys. So the total would mean that there's 7 of them total, and 3 of the 7 would be girls. So 3/7 of that total, 238, would be 102, and that leaves us to figure out boys. It would be 102 238 minus 102. Or you could do 4/7 times 238, and you should get the same answer of 136 boys. All right. The ratio of sides of a polygon given. All right, here's an extended. Has a star by it because it's an extended ratio. The sides of a polygon are 2 to 2 to 3. So it's a three-sided polygon or a triangle. Making conjecture about the type of polygon described. All right, I kind of just gave it away. Hopefully you could figure out that since the ratio of sides of this polygon are 2 to 2 to 3, I think it's going to be a triangle. Specifically, if we have two sides to be the same, an isosceles triangle. All right. And lastly, another extended one. The measures of angles of a triangle are in the extended ratio 6 to 1 to 5. What is the measure of the largest angle? So if we have 6, 1, 5, that means out of a total of 6 plus 1 is 7 plus 5 would be 12. 6 of those 12 pieces would make up one angle. So the largest angle would be 6 out of 12, or 1/2 of all of those degrees, which would be a total of 180. So I think it's going to be a 90-degree angle. We have a right triangle here. But anyway, that is a basic overview of ratios and extended ratios. Now a little bit about proportions before we finish up here. So proportions, remember, are comparing, or an equation comparing two things. So kind of like right here. This is our proportion. A over B is equal to C over D. All right. Now the uh, cross products property. That's the first one we have here. It's not a theorem. It's just a property that we're highlighting. It says in a proportion, the product of the extremes equals the product of the means. Now, if you learn it as means and extremes, basically it's just the opposite corners. All right. So the extremes would be the red, the first and the last. The means would be the middle ones, the the second one or the bottom one on the left, and the top one on the right. So the product of those two would be set equal to each other, and that's the cross products property. You might remember it more as taking, you have A over B equal to C over D. You actually cross them, the products. All right, the A times D then is equal to the C times B or the B times C. All right, so the example over to the right is with numbers. 2/3 equals 4/6. We know that's true, but we can check it using the cross products property. So 2 times 6 would equal to 3 times 4, and that's true there. All right, the other piece here are some special properties of proportions, assuming none of these pieces are not equal to 0. So here's one property. A over B is equal to C over D. There's our proportion. It would be equivalent to if you'd flip it. B over A is equal to D over C. You can always flip the whole thing and it won't change the way this proportion works. So rewrite the reciprocal of each ratio. So 2/3 equals 4/6. Same thing would be true if you flipped it and said 3/2 is equal to 6/4. Interesting property. Second property we have there, A over B is equal to C over D, would be equivalent to A over C is equal to B over D. So you can flip here the B and the C, and it'll still work out. I never thought about that until I saw this, but you can switch the two means, or the two middle ones, the B and the C. So 2/3 is equal to 4/6. If you flip the 3 and the 4, 2/4 is then equal to 3/6, and that's true. So that's the second property. And one more third unique property here. If we have A over B equal to C over D, it's basically like the addition property of equality, and we're just adding them to the top of each one. But if you add, it's if you're adding what the denominator would be. So see there, that's where it's slightly different from the addition property of equality. So if we have A over B is equal to C over D, you could say also A plus B over B is equal to C plus D over D. So here's a number example. 2/3 equal 4/6 we're working with. It would be the same as 2 plus 3, so plus that denominator, so it'd be 5/3. And 4 plus 6 would be 10 over 6. 10/6, and that does work out. They would reduce the same thing. Unique properties of proportions that may come in handy. So let's do a couple examples with them, and then I'll let you go and do some of this on your own. So first one, it says use algebra to solve the proportion. We're going to do number 6 and number 9, I think. So first one, again, we are using the cross products property, cross multiply. So we have 3 times 25 equals 5 times x. And when you divide both sides by 5, it would be 75 equals 5x. Divide both sides by 5, x is equal to 15. And then here's the other one that I want to show you. And these are where they get a little bit more tricky. But we have 3x minus 1. Whoa, it's moving on me. Times x plus 2. Okay, here's when some algebra comes in. But equals the 2 times the negative 2. So we know that 2 times negative 2 is going to be negative 4. So we'll leave that as negative 4 over here. But then we have to do the FOIL method is one way to do it. Otherwise, you're distributing both parts. So I'm going to do the first. It's 3x times x, so it's going to be 3x squared. Outsides, 3x times 2, which would be 6x. Insides, which would be negative 1 times x, which would be minus 1x or plus negative 1x. And then the last, which would be negative 1 times 2, which would be negative 2 or plus negative 2. So when you simplify that a little bit, you've got 3x squared plus 5x minus 2, but I'm going to add 4 to both sides first. So we have 0 by itself, so we can factor this thing. And plus, so it'd be plus 2 equals 0. Alright, so just like magic, I just did a little bit on this for you. What I did was use this quadratic formula. There's many different ways you might remember to factor this. I wanted to try the quadratic formula because I haven't done it in a while. And that is minus b plus or minus the square root of b squared minus 4ac all over 2a. I plugged in, this would be your a over here, this would be your b, this would be your c, and what I got out was negative 5 plus or minus the square root of 1 all over 6. So that goes two different ways because we have the plus or minus. We'd have negative 5 plus, that's 1, square root of 1 is 1, over 6, and negative 5 minus 1 over 6. So our two possible answers for x would be negative 1 plus, negative 5 plus 1 would be negative 4 over 6, would be negative 4/6 or negative 2/3. And this one would be negative 1, or negative 5 minus 1, which would be negative 6. All over 6 would be negative 1. So we have two answers for x. X could be equal to negative 1. Oops. Oops. There we go. X equals negative 1, or it equals negative 2/3. So there are two x values there. So if I did that right, hopefully I did. But that is one way to find, without factoring it, to find the values of x. Again, you could factor it, and then you could solve the two parts of that for x as well. So I'm going to leave these last two for you to do, numbers 10 and 11, and then the closing question. It says use the graph, write the ratio in simplest form. So you're going to have to find the distance of AD and AB. Well, that one should be easy. Don't have to necessarily use the distance formula because it's all right there. But then this one you'll have to find the slopes of BE and AE and write the ratio in simplest form for that one. So good luck to you on that. Answer the last two closing questions if you will, and think back at what you learned, what maybe you struggled with. For this goal, I can write ratios and solve proportions. We'll see you next time.